Hello, hello, hello. Wait a minute, guys. Please let me check the audio. Hello, hello. Okay. Audio is clear and everything looks good. I think we can start now. So, good evening, all of you. Myself, Sachin Yadav, and today we are going to start new chapter. That is our moving charge in magnetic field. Okay. So, we are going to discuss the previous year's mains questions, J mains questions. After that, wait a minute. Okay. In this video, we are going to discuss all the PYQs, JEE mains PYQs on magnetic effect of electric current. Okay. In the next video, we are going to discuss advanced, okay, advanced questions. So let's start. So here is our first question. If you can't see, let me zoom. Okay, now it is more clear. Figure shows a current carrying a square loop ABCD of edge length A lying in a plane. If the resistance of ABC part is R, means the resistance of A, B and C, this wire is R, and the resistance of ADC wire is 2R, right? Then the magnitude of the resultant magnetic field at the center of the square loop. सेंटर पे अपन को मैग्नेटिक फील्ड बताना है, सेंटर में मैग्नेटिक फील्ड कितना है। देखो दोनों पैरेलल में लगे हैं, तो जो वोल्टेज होगा, वोल्टेज ड्रॉप होगा, सेम होगा। तो इसमें से जो करंट जाएगा, ए बी सी में से जो करंट जाएगा वो क्या होगा। सपोज कर वोल्टेज ड्रॉप वी है तो वी बाई आर जाएगा, और ए डी सी में से कितना जाएगा, वी अपॉन टू आर। मीन्स करंट इन ए बी सी, करंट इन ए बी सी इज टू टाइम्स ऑफ करंट इन ए डी सी। ये समझ में आया। इसमें जो करंट होगा, सपोज करो इसमें आई बोला, तो इसमें कितना होगा, टू आई करंट होगा, आई नॉट सपोज करो। ओके, अगर इसमें आई नॉट करंट है तो इसमें टू आई नॉट होगा। तो अगर टू आई नॉट प्लस आई नॉट कितना होना चाहिए, आई। फ्रॉम एयर वी गेट आई नॉट इज इक्वल टू आई वी थ्री। तो इसमें कितना करंट है, आई वी थ्री, और ए वाला होगा टू आई आई वी थ्री। दोनों में करंट आ गया, दोनों में करंट की वैल्यू आ गई। नाउ अगर अपन इस पॉइंट पे अगर मैग्नेटिक फील्ड देखें, चारों देखो, जो स्क्वायर की चारों साइड्स हैं, ए बी बी सी डी एंड डी ए, चारों फोर्स लगाएंगे। देखो ए बी किस डायरेक्शन में लगाएगा, दैट इज इक्वल टू, अगर इसको अपन एक्स बोल रहे हैं, इस 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 डायरेक्शन को बाई बोल रहे हैं, और इस डायरेक्शन को जेड बोल रहे हैं। ठीक है, जेड मीन्स डॉट, डॉट इज प्लस जेड, जो अपनी तरफ आ रहा है उसको प्लस जेड बोल रहे हैं, डॉट, इसको डॉट से रिप्रेजेंट कर रहे हैं। ओके, तो जो ए बी वायर के ड्यू टू ए बी वायर द मैग्नेटिक फील्ड is if we apply right hand thumb rule, then we get inside means cross. Okay, AB के due to AB the direction of magnetic field is invert the Z plane, and due to BC it is, if you again apply the right hand thumb rule, then it is again in the cross direction, right? ये समझ में आया, ये समझ में आया कि नहीं, प्लीज कंफर्म। ओके, लाइव स्ट्रीम सही चल रहा है, क्रॉस डायरेक्शन में है, ए बी और बी सी का आ गया। नाउ ए डी, ड्यू टू ए डी इट इज इन द dot direction means outward the xy plane, and due to dc it is same, means in the dot means outward to the xy plane. Okay, so अब अपन पहले, ये तो आ गया डायरेक्शन, मीन्स इन दोनों की वजह से, ए बी और बी सी की वजह से सेम मैग्नेटिक फील्ड आएगा, मीन्स मैग्नीट्यूड में सेम रहेगा और डायरेक्शन भी सेम रहेगा, दैट इज इनवर्ड, एंड ए सी और बी सी की, ए डी और डी सी की वजह से आएगा आउटवर्ड। ठीक है, अब इसका मैग्नीट्यूड निकालते हैं, तो मैग्नीट्यूड ड्यू टू ए बी, ओके, मैग्नेटिक फील्ड बी इज इक्वल टू क्या होता है, अब मैग्नेटिक फील्ड का फॉर्मूला लगाएं, दैट इज इक्वल टू म्यू नॉट आई अपॉन 4 pi r, that is small r, sorry, that is sin theta 1 plus sin theta 2। अगर अपन इनवर्ट डायरेक्शन को नेगेटिव बोले, अगर ए बी इनवर्ट डायरेक्शन को नेगेटिव बोलें और आउटवर्ड डायरेक्शन को पॉजिटिव बोलें, तो यहाँ पर क्या आएगा, निगेटिव। ओके, सिमिलरली ए बी की वजह से आ गया इनवर्ट, प्लस बी सी की वजह से कितना आएगा, म्यू नॉट आई, मीन्स सेम आएगा 4 pi। magnitude and the direction due to AB and BC are same, as both are identical and the direction also same, right? So then we can directly multiply this whole equation by 2, as the direction and magnitude are same. Let me erase this, right? So from here we get B of AB, magnetic field due to AB plus magnetic field due to BC is equal to 2 times of 2 times of mu naught I upon what is I, that is 2IV3 upon 4 pi, what is R, means this distance, perpendicular distance from the wire to the point, means this distance, that is equal to AB2, that is half of the side of rectangle, sorry, square, that is AB2, right? Bracket sin theta 1. Here what is sin theta? If I zoom this, let me zoom this. If you can see, what is our theta? This is the theta. If I say theta 1 to this, then this is theta 2, right? Here is our theta 1 and theta 2. This is the angle sustained by the sustained at the point due to ends of the wire. Okay, so it is the angle sustained at the point where we wanna find magnetic field. Okay, here is our theta 1 and theta 2. As this is a square, then this whole angle is 90 degree, means theta 1 is equal to theta 2, and theta 1 plus theta 2 is equal to 90 degree, right? अगर आप इसको आप ध्यान दें, तो थीटा 1 एंड थीटा 2 90 डिग्री, दोनों इक्वल है, तो दोनों 45 के हो जाएंगे, ये आप सिमेट्री से निकाल सकते हैं। तो यहाँ से आएगा साइन 45 प्लस साइन 45 डिग्री। ओके, नाउ मूव टू द नेक्स्ट पेज। तो अपना आ गया बी ऑफ ए बी प्लस बी ऑफ बी सी इज इक्वल टू नेगेटिव ऑफ 2 टाइम्स ऑफ म्यू नॉट 2I/3 upon 4 pi, that is equal to AV2 into, that is 2 times of sin 45, that is equal to 2 root 1V2. Okay, from here we get 2, cancel out this and this will become 2 root 2. From here we get minus 2 root 2 upon 4 times of, and 1 2V3 comes here, and 1 2 is come on the upper, and mu naught I upon 4 pi a. So we get V of AB plus B of BC is equal to minus 8 root 2 upon 12 into 1 upon mu naught upon 4 pi a into I. right? Here is our value. ये समझ में आया? Now for other two sides, if we see for these two sides, that is AD and DC, what is the direction? That is plus, right? And what is the magnitude? Here if you see, the symmetry is same for all the four sections. Means A, if we name this point as O, then the symmetry for AOB and BOC and all other two are same, right? Then the angle theta 1 and theta 2 remains same for ADO and also for DOC, right? दोनों के लिए सेम रहेगा. Now, what is change in this for these two sides? That is the amount of current that is equal to IB3, as well as the distance, that is R, small r, from the wire to the center is also same, that is equal to AB2. In also in this case, both distance in this case and as well as in this case both are same. Okay, then what wanna change, that is our I, that is equal to, that is in this case IB3. Now apply the same formula, that is B of AD plus B of DC. And one more thing, that the magnetic field at point O due to both these lines AD and DC are same, as well as is magnitude as well as in direction, because both are pointing outward the xy plane. Okay, so in दोनों को we combine these two and we take as these two as separate, because the direction of these two are similar and these two are similar. Okay, and we combine these two in a single equation, and what we get, that is, here we wrote plus as the direction we take outward as positive. Okay, that is 2 times of mu naught IV3, that is current, upon 4 pi AV2 sine theta 1 plus sine theta 2. Same things, right? Now solve this and we get 2 times of mu naught IV3 into 4 pi into A into 2 into 2 times of IV root 2. That is, this cancel out this and we get 2 2 2, that is, okay, that is 4 root 2. Okay, that is 4 root 2 upon 12 times of, what we get that from 4 pi 2 I naught into 2 on 4. I think I write extra A4 here, right? I think I write one extra 4 here. Please check this. That is 4 times of A and this comes down. That is 4 into 2B3. And what is this 4 comes from? Okay, I write, I think, one extra 4. So it is 12. Okay, this is 4 3 is a 12. It is 2 root 2 4 mu naught I upon, and this is equal to pi A, right? Okay, this is, I think this is correct now. So what is net magnetic field? What is net? That is B net at point O, is equal to B due to AB, B due to BC plus B due to AD plus B due to DC. That is equal to minus 8 root 2 upon 12 mu naught I upon pi a plus 4 times of root 2 upon 12 mu naught I upon pi a, and this will gives us, that is, minus 4 upon root 2 upon 12 into mu naught I upon pi a. So this is our net magnetic field at point O. Understand? Do you understand this? Please once check the calculation. If I cancel out this, then we get this. Okay, minus root 2 by 3. Now it is correct. Pi a. Okay, this is correct in simpler form. Now move to the next question. Do you understand this? Please comment. If you have any doubt, please let me know. I will see your comments. Wait a minute. Let me see the comments. Okay. Now move to the next question. That is our this one. A uniform magnetic field of different strength B1 and B2, both normal to plane of the paper, exist as so in the figure A. A charged particle of mass m, mass of particle, that is mass is equal to m, and charge is equal to small q, at the interface at an instant move into the region 2, means just ऐसे इसमें से जस्ट ऐसे एंटर किया है जिस टाइम पे अपन ने इसको ऑब्जर्व, एट द टाइम व्हेन वी स्टार्ट ऑब्जर्विंग दिस, the particle enter just in region 2, at the time move into region 2 with velocity v, and the velocity of the particle is v at that time, and return to the interface. It continue to move into the region 1 and finally reaches the interface, means it travel into the, as you know, the moving particle of, means the particle moving with some velocity v, it follow circular path in magnetic field. Okay, so when it enter in magnetic field 2 in region 2, it follow the circular path and again redirect into the region 1. So here it enter again in the region 1. Suppose if we call this it this point as A and this point as V. Okay, and it again enter into the region 1 and finally reaches the interface, means again it reaches the interface. Suppose it reaches some point C again, right? C. What is the displacement of the particle during the this movement along the interface? Means the displacement of this particle P in this direction, in the x. If we call this direction as the direction of interface as x, then the direction in then we are gonna ask about the direction, means displacement in the x direction, means that is AC or BC minus AB, right? Both are equal. Sorry, this one is AC. This AC is equal to BC minus AB, right? If you know the radius, that is the radius of circle, that when a charged particle move in a magnetic field with a constant velocity, then it travel in a circular path. And what is the radius of that circular path? If you know, please let me know. That is QB sorry, MB by QB. Let me erase this. MB by QB, right? Wait a minute. is this. Okay. MB by QB. So for reason means the distance AB, this distance AB, that is equal to 2r. If we call this radius as r1, means in the region B2, the radius made by the particle means the radius of the path, if we call this as r1 and this as the r2. So here our r1 means for the region 2, it is equal to mass, what is velocity, that is v, what is q, that is b, and what is b, that is b1, sorry b2. For region 2 it is b2. Okay, now it enters into the region this. So in this region, as it inside with the same velocity, because the acceleration is zero, velocity don't change, means the magnitude of acceleration as the direction change. If I will explain you, as the direction of the velocity at every point is changing, then the acceleration should not be zero. Acceleration should not be zero as the direction changes, but the magnitude of v is equal to constant. In that respect, acceleration is constant, means in the respect of magnitude, acceleration is constant, then the velocity is not changing. With the same velocity v, it enters in the region 1 again. Okay, it enters the region 1 again, and what is the r2, that the radius of the path it form is equal to mb by qb. As m, b and q are the same, then what is our radius, that is b1. Oh, I think this is r2. Let me call this r2. Region 1, region 2 में r2, and this is r1. I think this is r1, sorry, this is r2, I think. Okay, now it is good. This is r2, sorry, this is r2 and this is r1. I got confused little bit in naming. Okay, let me correct this. Okay, now what is that? That is in region 1, that is equal to r1. Okay, now it is correct. So what is this distance AC now? If I ask you about the distance, if I ask you about the distance, wait a minute, wait a minute. I think, please let me check the internet connection. Okay, so what is the distance of AB, that is displacement AB, AC, sorry, AC, that is BC minus AB. What is BC here? BC, that is 2 times of R1, that is 2 times of R1 minus 2 times of R2 is our displacement, that is delta X, that is equal to 2 times of R1, that is MB by QB1 minus MB by QB2, right? From here we get 2mb by q. If we take out b1 as common, and what we get, 1 upon b1 as common, that is equal to 1 minus b1 upon b2, right? I think there is some problem in the network. Let me fix this. I think. Wait a minute. Okay, this one is correct. Now move to the next question. That is our third question. Okay, this one. Let B1 be the magnitude of magnetic field at center of circular coil. Means there is a one circular coil like this. And here is our magnetic field is B1. Okay, here is our magnetic field is B1. Hmm. And the radius of this coil, that is, this is capital R. Let B2 be the magnitude of magnetic field at an axial distance x from the center. Means at a distance x, that is x, from the center, magnetic field is B2. Right? Means this one in this direction. Like this. It depend on the current direction. In which direction of current. Okay. Okay. So here is our this is R, this is X, and here is our B2. Now what is given with the magnitude of magnified axial distance X from the center. So from the center for X raised to R, X is to R, the ratio is our 3v4, 3v4, and B2 by B1, B2 by B1. Then what is the formula for B1? If I ask you what is formula for B1, that is magnetic field due to a, if I ask for journal, that is at a distance x, what is that? If I generally ask at a distance x from the center, what is that? Mu naught I, I think mu naught I r square upon 2 times of r square plus x square minus x plus, sorry, plus x square raised to power 3v2. I got little bit confused. Okay, then that is, what is that x? That is the distance of point at that at the point we want to find the magnetic field from the center of the ring, right? Now if we look at the center, what is v1, that is at the center, that is equal to mu naught I r square upon 2 times of, if we put this equal to the 0, this is r cube, that is equal to mu naught I 2r, that is v1. And what is b2? That is equal to mu naught I r square. If I multiply this by r and this by r, means if I multiply both denominator and numerator by r, then what we get? It, I think it make our calculation easy. Okay, then it will become b2 is equal to mu naught I upon 2r into r upon, I think, root of r square plus x square raised to power 3, whole raised to power 3. Do you understand? Do you understand this? Do you understand this? Now let me move to the next page. What is our b2? B2 is come out to be, what is b2? That is mu naught I by 2, that is mu naught I upon 2r r upon root of x square plus r square, that is of whole raised to power 3. And what is this term? What is this? That is equal to, I think, b1 mu naught. What is b1? Mu naught I upon 2r, right? Mu naught I upon 2r, that is equal to b1. Then we can replace this term with b1. And what is the ratio? That is r upon that distance, that is equal to, if we say this as theta, and what is this? R upon root of r square plus x square is equal to sine theta, that is sine theta. If this is the ratio of XVR means if this is 3 and this is 4, about this, what is this? That is equal to 8, 5, right? By applying Pythagoras theorem. And what we get, the ratio of RV root of R square plus X square, that is equal to ratio of this side and this side. XVR is equal to, okay. Now what is the ratio of RV hypotenuse, that is root of R square plus X square, that is equal to 4V5. Okay. So if I write B2, B2 is equal to, I replace this by B1 and write this as 4V5 whole cube. That will give you B2 by B1 is equal to 64, I think, upon 20, 125. Okay, this is our final answer. This is our final answer. Okay, and let's check for the answer. That is 64B means we are going to B2 by B1. Okay, we are gonna ask about B2 by B1 or the okay. So this option A is our option A is correct, right? Understand? Now move to the next question, third. Please focus here. Consider a long straight wire of circular cross section of radius A. Means this is our wire, that is cylindrical wire. Oh, wait a minute. It should be little bit straight. Okay. Mm, like this. Okay. Consider a long straight wire of circular cross section of radius A, means that the distance radius of this is A. Please, please notice one thing. If you are preparing for JEE Mains and JEE Advanced, then try to assume the question, means make a 3D vision, 3D model like in your mind. Okay, that good for you because the advanced question need more visualization. If you uh, see the mains JEE Mains question, it is easier. You can hit them by directly formula, but it is not in the advanced. You got stuck in the advanced question, right? So please try to visualize the question. Try to make a 3D model, 3D image of the question. It is helpful for you for the JEE advanced question. Okay. Okay, the current is uniformly distributed across this cross section, means current is uniformly flow through the whole cross section. The distance from the center of the wire cross section at which the magnetic field inside the wire comma outside the wire is half of the magnetic possible field anywhere due to the wire will be. Means we have to find two location, means one is inside, means something at a distance x. If I draw a ring inside the cross section, small cross section inside the cylinder, and one is at a distance r, that is outside the wire, then the magnetic field at both the points should be should equal to b max v2, or maximum possible magnetic field due to this wire. Okay, where b max is the maximum possible magnetic field due to this wire. Understand? So if you know the ampere circuital law, what we do, that is b dot dl line integral of uh, magnetic field, that is equal to mu naught into I enclosed, right? Right? If we see here, for a particle at a distance x, suppose at a distance r, What is the line integral? That is dl. What is that? Mu naught into I enclosed, that is equal to B is equal to mu naught I upon 2 pi r, right? What is this R? What is this I enclosed? Means this I is equal to current inside the R loop, means the current inside the within the distance R, that the cylinder, that small cylinder with radius R. Okay, so from here, if we know, if you recall, the maximum magnetic field for this is equal to mu naught I, that is the current through whole this hole, right, upon 2 pi 2 pi r, that is capital R. So this is the maximum magnetic field that produced as at the surface of the cylinder, right? Understand? Wait a minute. Now move to the next page. So what we get, B max is equal to mu naught I upon 2 pi capital R. Now, as I will check for the small radius, that is for I check for small radius for small r, and by this side I will check for the for capital R, right? For small r, if I see what is the current density throughout the cross section, what is current density? That is I upon A of cross section, that is current density. If I density of DC बोल देता हूँ इसको, current density, I will call it as a current density. What is I? That is I. What is A? That is 4 pi r square, that is current density, and what is amount of current flowing through small radius r, means small cross section of radius r, that is equal to I upon 4 pi r square into oh, 2 pi r square, I think 2 pi, I, sorry, pi r square, sorry, I wrote the mu naught value, I used it, that's why it is in habit, sorry for that. Okay, that is equal to pi small r square, that is equal to CD. Okay, this is not CD here, it is the current I enclosed in the small radius r, right? That is I enclosed is equal to I times of r upon capital R whole square. And now for capital R, means r greater than, that is the radius greater than the radius of the cylinder. For that we get r, please mark it as RO, because you got confused in the R and R, because both are the same. We take both are same, then it is little bit confusing. So here we get what is I enclosed, that is equal to I upon, if you remember, please, if you remember, we take the whole area in the line integral, we take the whole perimeter, means perimeter of the bigger ring, not only of the portion from that the current is flowing. Please recall this thing, and if you don't recall, please remember this thing. If we take the line integral at a distance r, then we take the parameter, we integrate along that whole perimeter. Okay, so from here I will get I integral is equal to pi capital R square, and from here that is pi r naught square, that will get I is equal to r naught sorry. Wait a minute. Sorry, current density not for that. It's 1 second. We direct apply. Let me remove this. We direct apply ampere circuital law for this, right? So we need to I enclosed for this. For this, I enclosed is equal to I because the outer radius, that is outer radius, include the whole current within it. Okay, the whole current is within inside the bigger radius. If you see the bigger radius R. Okay, I enclosed is I. Now, if we apply ampere circuital law for this, that is B dot dl is equal to mu naught I enclosed. What is I? That is capital I. B into what is dl? That is 2 pi capital sorry, R naught, that is this, into mu naught I. From here we get B is equal to mu naught I upon 2 pi R naught. And for this, B for R naught and B for small r. If we see B for small r, that is equal to mu naught I, that is equal to I into R upon R whole square upon 2 pi small r. From here we get mu naught I R upon 2 pi R square, right? We get value of BR and BR naught, and these both values are equal to mu naught I upon 2, what is the maximum, that is equal to upon 2 pi capital R, right? That is capital R, and this is also equal to mu naught I upon 2 pi capital R. From here we get 2 pi cancel out 2 pi and mu naught I cancel out, sorry, half, I think half of this, right? Half mu naught I and also the half of this, sorry. From here we get R naught is equal to 2 times of capital R, and for this we get it's mentioned as half, no, 4 times of mu naught I upon 4 pi a. What is I? That is for R by R naught, and that is equal to half of. Let me see the question once again. I think the current condition in this question, the distance from the center of the wire cause at a Western magnetic field is half of the maximum possible at the point. Okay, it is half of the maximum possible distance. Okay, if we see half of the half of the possible distance, that is mu naught I upon 2 pi. It is the maximum and it is the half. So that is equal to half of maximum, that is mu naught I upon 2 pi capital R. That is equal to what is I enclosed, that is mu naught I, that is I by R square upon capital R square. I enclosed, as it is uniformly distributed upon 2 pi R mu naught I upon 2 pi small r, right? So from here we get mu naught I upon 2 pi r cancel out, mu naught I upon 2 pi and 1 r from here. So from here we get what 1 r cancel out this r. So from here we get small r is equal to capital RB2. Okay. We get small r is equal to capital RB2 and capital R is bigger R is equal to 2 times of R. Right. Now it is correct. Which option is correct? I think C option is correct. राइट, अंडरस्टैंड? ये समझ में आया आपको? यहाँ पर मैंने एम्पियर सर्किटल लॉ भी थोड़ा, आई विल एक्सप्लेन एम्पियर सर्किटल लॉ लिटिल बिट, and from there you can directly hit the question. If you know the formula, you can also directly hit the question. Okay, now move to the next question. That is, it is simple. Please try to do by yourself once. Okay, please stop the video and please pause the video and try to do by yourself first and then start the video, right? So A, B, C, if I mark this point as A and this point as B and this infinity as, it is infinity, okay. Or I can either say, if I mention, okay. So that if I explain you the magnetic field, what is they gonna ask? An infinite wire as a circular band of radius and carrying current I as shown in the figure. The magnetic field at the point O of the arc is given B. Means we what is the, they ask the about the magnetic field, magnitude of magnetic field at point O. If you know the magnetic field due to a parallel wire, if we place a take a point along the parallel infinite wire, then the magnetic field at that point due to that wire is 0. So the magnetic field due to this wire from B to infinity is 0, as it is on the axis of the wire. So magnetic field due to this is equal to 0, means due to B to infinity is equal to 0, right? Now what is remaining, that is this circular ring, means 3 by 4 circular, and what is that, another infinite wire that is from A to infinity, right? So what is the magnetic field due to this infinite wire? If you recall, what is the magnetic field due to semi-infinite wire? That is equal to, I think, mu naught I upon 4 pi r, where r is the distance of point from the line. So here from we get mu naught I upon 4 pi a as the distance of this from distance of a from the wire is a. Now b due to circular, this is b due to parallel wire and b to the circular wire. If I see is write is as a bc, means magnetic field due to circular wire. Okay, so from here we get what is the formula for the circular rings. What is the formula for that? That is mu naught I upon mu naught I upon, if you remember the formula, that is equal to mu naught I upon, it is 4 pi, wait a minute, mu naught I upon, that is 2r and sine theta upon 2, I think, theta upon 2, sorry, theta upon 360. It is for, it is in the, it is for uh, a section of circle for in the magnetic, I will confuse in that formulas. Okay, दोनों फॉर्मूले में थोड़ा कंफ्यूज हो जाता है इलेक्ट्रिक फील्ड और मैग्नेटिक फील्ड वाले में. ओके, सो द फॉर्मूला इज फॉर दैट. अगर आपको ऐसे नहीं आ रहा तो आप डायरेक्ट वैसे निकाल सकते हैं. मैं आपको इसका प्रूफ भी बता दूंगा अगर टाइम रहा तो लास्ट क्लास में. ओके, नहीं तो आप डायरेक्ट फार्मूले के थ्रू जाइए. लेट मी रिमूव दिस. थोड़ा मैग्नेटिक फील्ड और इलेक्ट्रिक फील्ड वाले फार्मूले थोड़े सिमिलर हैं तो उनमें कन्फ्यूजन होता है. So what is magnetic field at O due to circular rings? That is equal to mu naught I upon, what is radius, that is 2a, into sine. What is value of sine? That is theta. What is theta? 270. Sorry, it is not sine. Please remove this. It is 270 upon 360. Okay. If you assume like this, it is the circular rings, and what is the uh, magnetic field at the center due to this? That is mu naught upon 2r. If you remember this, what is the magnetic field? I will tell you in the last question. That is this. That is mu naught I upon 2r, right? Similarly, here the due to the whole ring, the magnetic field is mu naught I by 2r. If we cut a particular section, if we cut this section, and what is the remaining? What is the final magnetic field? That is we multiply the remain for we calculate for the final algebraically, like 360 minus theta upon 360. We just calculate for only this one, means, understand, we remove this portion and we only calculate for this portion, so directly we written in the form of angles. So from here we get BOC is equal to mu naught I upon 2a into 270 upon 360. If we cancel out this, that is I think 3v4, or you can directly see this. If this is 90 degree, that is obviously 3v4th of the circular ring magnetic field due to circular rings, or it is same. Okay, so we get 3v8 times of mu naught I upon a, and due to this a, it is mu naught I upon 4 pi r. And once please check the direction. So due to this circular ring, what is the direction? It is, I think, cross. Okay, no, due to this. Okay, what is this? What is due to this? Also due to this, it is also in the cross direction. Okay, invert the plane. So what is the b net? That is equal to b parallel plus b OC. That will gives mu naught I upon 4 pi a plus 3v8 times of mu naught I by a. Right, this is our final answer. Understood? Now move to the next question. That is our sixth. Consider a long thin conducting wire. Consider a long thin conducting wire carrying a uniform current I. Means there is a uniform wire that is carrying a current I like this. This is carrying a current I. A particle having mass m and charge q. Mass m, that is released at a distance a from the wire with a speed v naught along the direction of the current in the wire. Okay, me okay, there is our particle be released it with a velocity v naught in the direction of current at a distance. This is a, right? This is a, along the direction of current in the particle get attracted to the wire due to magnetic force. The particle get attracted due to the wire due to magnetic force. The particle turn around when it at a distance of distance x from the wire. The value of x is, means, if you can see, as we release the particle, it follow the circular path, and after some time it changes direction and move in this direction. The direction is altered, and the distance now is become x. Okay, if we see, okay, if we see, the magnetic field is in the cross direction, and if we apply left hand thumb rule, sorry, right hand thumb rule for finding the direction of force, that is equal to F is equal to Q into V cross B. If we apply this, and we get what we get, the direction of force, that is in this direction, right? Understand? Please wait a minute. Let me check one thing. Right. Now, let us start. If we mark this point as A and this point as B and this point as C. Okay. Now, what is the force acting on A at point, force acting on particle at point T? That is force is equal to Q B B in the magnitude. Okay. And what is the velocity of this particle? That is, if we write the velocity, that is equal to Vx. If I write this like in this, if I write this x plane, this x direction, and this is the y direction, so that is equal to Vx in the negative I cap plus Vy in the j cap. Do you understand this? I resolve the velocity component in two directions, x and y. Understand? And now, what is the magnitude of magnetic field at a distance a from, at a distance a? That is, if I take a general point, that is r, then what is the magnetic field due to wire? That is mu naught I upon 2 pi r, right? Mu naught I upon 2 pi r. And what is our force? That is equal to q v cap into b cross b cap. Okay. And what is this direction? That is in the minus k cap. Understand? Now, if we see f cap is equal to q times of what is b, that is equal to minus v in the x I cap plus v in the v in y j cap cross minus k cap. And what we get, if you do the vector product I j k, and what is in the minus vx, it is vy, and it is 0 and 0 0, it is minus 1 minus k cap, right? On solving this, we get, if you solve this whole things, you got I cap cross j cap, and you solve this, f cap is equal to q times of, it comes out to be minus vx in the j cap plus minus vy in the I cap, right? If you solve this cross product, you get this. Okay, please do this by yourself. Okay, it is simple. I just directly write the result. From here we get, what is f? F is equal to q, that is equal to, okay, I only write the direction here, where is the magnitude, so we get q mu naught I upon 2 pi r into minus vx in the j cap minus vy in the I cap, right? Do you understand this? Please let me know. Do you understand this? Now move to the next page. This question is good. Means if we talk about at the level of maths, this question is very scoring. If you do this question, you get means directly above all the average student. Your rank is directly boom, right? So it is a good question. What we get our F is equal to mu naught qi upon 2, what is that, 2 pi r, 2 pi r, that is minus Vx in the j cap minus Vy in the I cap, right? Means if I write this like um, Vy in the I cap minus Vx in the j cap, right? ये समझ में आ गया? इसको हटा दो अभी। ओके, अब अपन दोनों फोर्सेस को अलग अलग डायरेक्शन में in the x direction. If we see the force in the x direction, that is equal to mu naught qi upon 2 pi r into vy. कुछ देर के लिए डायरेक्शन को अभी रहने दो माइनस आई के एफ, ओके, into vy. If we see only the magnitude, okay, what is force, that is equal to m into a, that is equal to mu naught qi upon 2 pi r into vy. From here we get a in the x direction is equal to mu naught qi upon 2 pi r into m into vy. From here we get what is acceleration. If we see, we we should not involve the uh, time term, okay, so we have to write the acceleration in the form of v and r. That is, if you recall, what is our acceleration in the form of r, means differential form with respect to r, that is equal to v into dv by dr. So that is in the x direction, both are in the x direction, that is equal to mu naught qi upon 2m pi r into vy. From here we get dv in the x direction into v in the x direction upon by is equal to mu naught qi upon 2m pi r into dr, right? Do you understand this? Please write this pi here, okay. So we get an integral form, right? यहाँ से अपना एक इंटीग्रल फॉर्म आ गया। ये बहुत अच्छा क्वेश्चन है, इसलिए मैं बोल रहा था, इसलिए मैंने इसको जानबूझ के ऐड किया था। ये बहुत अच्छा क्वेश्चन है। Now we get all the values. Here we get in the terms of r on the right side, and here we get two terms vx and vi. Now we have to eliminate vy, that is equal to vx square plus vy square is equal to v, okay. From here vy is equal to v, sorry, this is v square minus vx ka whole square, right? As v is a constant throughout the, if we see in the magnitude, v is constant throughout the motion, okay. So we replace vx into dvx upon root of v square minus vx square is equal to mu naught qi upon 2 pi m into dr upon r. Now we integrate this. Now what is the limits? Now focus on the limits, please focus on the limits. Before integration, let me substitute this with another parameter, okay. Let me substitute this, means v square minus vx square is equal to z square. I change this in different parameter, so this will be get 2vx into dvx is equal to 2z dz. If we differentiate this, from here we get dvx is equal to vx, okay. Now put this value into the, that is what we get vx into dvx upon root of v square minus vx square is equal to mu naught qi upon 2m pi into dr upon r. Now I substitute root of b square minus vx square as z. From here I get what is the I get what I get, that is equal to minus 2 vx dvx is equal to 2 times of z into dz. From here I if I substitute this, then what we get, that is z into dz upon z, z I think, right? If I put this is equal to z and v dx is equal to z into dz. Okay, I this cancel out this and we get dz, that is equal to mu naught qi upon 2 pi m into dr upon r. On integration, on integration what we put limits. Okay, at r is equal to what is the initial position, what is our initial position, if you see what is initial r, that is equal to a, that is equal to a. What is the initial limit, that is equal to a, and what is the final limit, that is our this one. Suppose call this distance as something like x dash, suppose it is x dash. Okay, so from a to x dash, what is our z at x is equal to when the distance is a, what is the velocity, it is in the y direction, there is no velocity in the x direction, then what is vx is equal to 0. If vx is equal to 0, then what is the z, that z is equal to v, that is v naught. If I call it as v naught, and it is v naught, and what is finally the velocity in the x direction, what is the value of z final when the it reaches at the x dash, means if I told you when it reaches x dash in this direction, there is no velocity in the y direction, it is purely in the x direction. So then vx is equal to v and the z will become, means vx is equal to v and this z is equal to 0. Understand? Understand this? From here we get minus v naught is equal to mu naught qi upon 2 pi m into ln r, and I put the value, that is x dash by a, x dash by a. Understand? From here we get into, from here we get ln of x dash by a is equal to minus of mu naught qi upon 2 pi m into v naught, and x dash is equal to 8 times of e's power minus mu naught qi upon 2 pi m v naught. अंडरस्टैंड? ये समझ में आया आपको? ये डायरेक्ट कैलकुलेशन से आ गया. ओके, ये सही लिखा है ना मैंने? ओके, इधर गलत हो गया ना, और सॉरी सॉरी. दैट इज इक्वल टू वी नॉट इंटू 2 पाई एम अपॉन यू नॉट क्यू आई. अंडरस्टैंड? ये नहीं होगा, ये होगा. Okay, in the negative, and this will x dash, please wait a minute. Okay, this x dash is equal to a into e's power minus, what is that, uh, 2 pi m v naught, 2 pi m v naught upon mu naught qi, mu naught qi. Understand? So this is our x dash for the location b. Okay, I think it is location b. Okay, okay, for B. Now we apply same thing for from B to C. Means we gonna find the x value of x. I know it bit little bit longer, but please focus. Okay, ये क्वेश्चन थोड़ा लंबा है मुझे पता है, लेकिन प्लीज फोकस कीजिए. अगर ये हो गया, अगर ये आपको एक बार क्वेश्चन समझ में आया तो आप ये एडवांस लेवल का क्वेश्चन समझ में आ रहा है. अगर ये आपको एक बार समझ में आ गया तो सब सॉर्टेड है, क्योंकि अगर ये आपने कर लिया तो ओवरऑल आपकी रैंकिंग, सच बता रहा हूँ, मोस्टली कुछ लड़के इस क्वेश्चन को छोड़ के आएंगे। जो प्रॉपरली आईआईटी एडवांस के लिए प्रिपेयर कर रहे होंगे वो ही इस क्वेश्चन को हिट कर पाएंगे, वरना एवरेज जो स्टूडेंट होते हैं जो बोर्ड से जेई मेंस का पेपर देने जाते हैं वो मोस्टली इसको छोड़ के आएंगे। तो ये एक स्कोरिंग क्वेश्चन है, समझ में आ रहा है? प्लीज फोकस हियर। नाउ व्हाट इज अवर वेलोसिटी? It is, what is our velocity at point B, that is in this direction. Now it is in this direction. As the particle begins to move in the left and downward direction, so what is our V? That is Vx in the I cap and Vy in the minus Vy in the Z cap. What is the force acting on them? That is Q into V cross B, that is minus Vx in the I cap, Vy in the Z cap into V cross B. What is B? That is minus K cap. Understand? That is our, from here we get force is equal to into mu naught I upon 2 pi r. Understand? This is the factor with the V. Okay. It will become mu naught q I upon 2 pi r. And if you cross product these two vectors, we get minus Vx in the z cap minus Vy in plus Vy in the I cap. Okay, I write that directly because if I do this, then it will become more long. Okay, the video become more long. Please let me do fast. Okay, the same method we apply again. We find the velocity in x-y direction and again do the same thing. Now, what is the velocity force in the x direction? That is equal to mu naught qi upon 2 pi r into vy. Same again. Mu naught I qi into in the x direction, and what is the direction? Vy in the I cap plus I cap. Okay, plus I cap. From here, that is a in the x direction is equal to mu naught qi upon 2 pi r into vy upon, if I move this mass here, from here we get, please let me remove this. Okay, so from here ax is equal to mu naught qi upon 2 pi rm into vy, right? That is, if we write this at vx into dvx upon dr into vy, if I write this as mu naught qi upon 2 pi m into 1 vr. From here we get vx, same equation. Okay, but the one thing that is different, I write this in speed. After that I explain what is change, here. Okay, it is change about the limits. Okay, I write this directly, please. ये सेम थिंग है जो मैंने पहले बताया था। तो फ्रॉम हेयर वी है वी एक्स इंटू डी वी एक्स अपॉन रूट ऑफ वी नॉट स्क्वायर माइनस वी एक्स स्क्वायर। अंडरस्टैंड? दैट इज इक्वल टू म्यू नॉट क्यू आई अपॉन 2 pi m into dr upon r. Now मेन थिंग्स स्टार्ट फ्रॉम हेयर। जो मेन चीज है वो यहाँ से स्टार्ट होती है। दैट इज इक्वल टू वी एक्स डी एक्स अपॉन वी एक्स सॉरी root of v naught square minus vx square is equal to mu naught iq upon 2 pi m integration we need dr upon r. ओके, सो सेम चीज अपन फिर से इसको z को सब्सटीट्यूट कर देंगे। दैट इज जेड स्क्वायर इज इक्वल टू वी स्क्वायर माइनस वी एक्स स्क्वायर, एंड फ्रॉम हियर वी गेट 2z dz इज इक्वल टू माइनस 2 times vx dvx. From here we get this is equal to dz. Okay, understand? dz, and that's it is equal to mu naught I q upon 2 pi m dr upon r. Now we will integrate. A main thing that will change here is the limits. Please focus on the limits. As we can see at point starting point B, what is the that is in the vx direction, and this is in the y direction. Initially here at point V, what is the distance? That is x dash. And what is the z? What is z? If we see the y, there is no velocity in the y direction, the whole velocity in the vx direction, that is equal to b. So z is equal to 0. Okay, z is equal to 0. Understand? Okay, one, I think one negative is come here. Okay, because it is vx and we convert it into vx. Okay, right? Understand this? Now if x dash, if we reaches at point c, means as it move as like this and we reaches at point c, if we reaches at point c, what is gonna happen? The velocity only in the y direction, negative y direction, there is no velocity in the x direction. So here if we put vx is equal to 0, so then what do we get? Z, that is equal to v in the x direction, that is equal to v naught. From here we get minus v naught is equal to mu naught iq upon 2 pi m ln, what is that? X upon x dash. From here we get ln x upon x dash is equal to minus v naught 2 pi m upon mu naught iq. From here we get x is equal to, sorry, if I altered this, that is x dash is equal to x times of x is equal to x is, sorry, x is equal to x times of is power minus 2 pi m b naught upon mu naught iq. Understand? And here we get the value of x in terms of x dash, and what the value of x dash we have calculated. What is the value of x dash? Okay, what is the value of x dash? That is equal to a into e power minus mu naught qi upon 2 pi m b naught, right? Sorry, it is not the value, it is the value minus v naught 2 pi m upon mu naught. Okay, so if we put the value of x dash, that is x is equal to x dash, that is equal to 8 times of e power minus 2 pi m naught, sorry, m v naught upon mu naught iq into, what is this value? This is same as that, then it is become 2 times. So from here we get our final value of x is equal to 8 times of e power minus 4 pi, and what is that? 4 pi m v naught upon mu naught qi. Understand? So it is really a lengthy question, but is worth it. Okay, उस लायक है, इसको समझाने लायक है, क्योंकि ये एडवांस लेवल का क्वेश्चन है और ये एक स्कोरिंग क्वेश्चन है, तो प्लीज इसको समझाना मेरे लिए इंपॉर्टेंट था। मैंने जानबूझ के इसको ऐड किया था, मुझे पता था ये लॉन्ग होने वाला है, लेकिन मैंने जानबूझ के ऐड किया था। प्लीज आप फोकस कीजिए, प्लीज फोकस कीजिए, बहुत इंपॉर्टेंट क्वेश्चन है। सबसे पहले अपन ने क्या किया, ए से बी तक की ट्राजेक्टरी को डिस्टेंस निकाला, ए एक्स डैश, व्हाट इज द डिस्टेंस इट कवर हियर, एक्स डैश। देखो सबसे पहले प्लीज डोंट से दैट अगर ये सर्कुलर पाथ फॉलो कर रहा है तो ए एक्स डैश होगा तो ए भी एक्स डैश होगा, ये बिल्कुल नहीं होने वाला, क्योंकि ऐसे ऐसे अपन लेफ्ट साइड को मूव करते आ रहे हैं। बी का डायरेक्शन, बी का मैग्नीट्यूड क्या है, व्हाट इज मैग्नीट्यूड ऑफ बी, इट चेंजेस with respect to r. what is the v? that is mu naught I upon 2 pi r। जैसे जैसे आप उसके क्लोज जाते जाएंगे आर का वैल्यू कम होता जाएगा और बी कम होता जाएगा, तो ये चेंज करेगा, इसलिए अपन ने ये सब झमेला किया, वरना तो अपन डायरेक्ट निकाल देते, कोई प्रॉब्लम ही नहीं था। अगर बी कांस्टेंट होता विद रेस्पेक्ट टू आर तो अपना डायरेक्ट हो जाता। समझ में आया? तो फ्रॉम हियर फर्स्ट वी गेट द फोर्स इन टर्म्स ऑफ वी एंड वी क्रॉस प्रोडक्ट हेयर, and we get the velocity as a function, f as a function of velocity. From here we find the acceleration. Okay, and then we convert acceleration in terms of velocity and we find the velocity in the x direction. From there we find the distance x dash. Okay, and same things we apply for from B to C. Right, understand? ये क्वेश्चन अच्छा था, प्लीज इसमें इसको एक बार फिर से देखिए, ये अच्छा क्वेश्चन था सच में. Now move to the next question. What is that? N equally spaced charges, each of value q. Okay, means there are q charges. Sorry, there are n charges. That is capital N charges, equally spaced charge, each of charge q. Okay, सबका charge q है. A total n number of charges are placed on a circle of radius r. The circle rotate about it at its axis with the angular velocity omega. Means this whole scenario rotate with the omega in the horizontal plane as shown in the figure. A bigger Amperial loop B means that B. This enclosed both this and this point. Okay, within it, like one ring is big and it inside the another ring, means B is bigger than the this ring and it is inside the B. This whole system is within the B and B is perpendicular to the plane of this system, right? A bigger imperial B enclosed the whole circle whereas a smaller imperial loop A enclosed a small segment. Means here A is small, enclosed only the one segment, only the perimeter, only one side of this wire, means this ring. The difference between the enclosed current IA minus IB for the given amperial loop, means what is the difference between IA minus IB? We have to find the difference, that is IB A minus IB. If we talk about the IB, if you see, suppose this rotate like this. Okay, this is here. Okay, the direction of rotation is mentioned here, that is omega. In that, if we see from the, it is like this. So if we see at this point, what is the uh, direction of current? If I see what is the direction of current, what is there? If suppose if you see from the front, means from this direction, if you see from the this direction, okay, if you see from this direction, the direction of the current is dot, means towards you. And what is the direction for this? That is cross at that point, at this point, right? So the number of charge particles come inside, same at that same time, same amount of charge particle going outside the loop B, right? As here it is dot and it is cross, so an amount of current come inside is equal to amount of going outside. If you see from there, you can understand this, right? So what is that? I for B enclosed is equal to 0, because amount of charges come is equal to amount of charge leave this, means cross this, right? Understand this? Now इसको कैच कर लिया तो क्वेश्चन हो जाएगा, फिर इतना टफ नहीं है क्वेश्चन. ये वाला समझ में आया कि नहीं? Now talking for IA. So IA, what is current enclosed in A? A में कितना करंट इनक्लोज्ड हुआ है? अगर अपन A में देखें, पहले तो अपन करंट निकालेंगे, दैट इज इक्वल टू what is current? That is Q by T, right? What is Q? That is N into Q upon what is time? What is time period of the T is equal to 2 pi by omega time period. Understand? That is equal to 2 pi by omega. From here we get I of A is equal to NQ upon omega upon 2 pi. Understand? From here we get IA is equal to this much. From here we get IA is equal to this. Then what is IA minus IB? That is equal to NQW upon 2 pi minus IB. That is equal to 0. From here we get answer is equal to NQW upon 2 पाई। ओके, दिस इज अवर आंसर। सिंपल क्वेश्चन था, बस आपको ये वाला चीज बहुत अच्छे से नोटिस करना था कि यहाँ से इन हो रहा है करंट, तो यहाँ से क्या हो रहा है, आउट हो रहा है। इफ यू सी फ्रॉम दिस साइड, you can directly observe this, and this is a bigger ring. Like if I tell you this will a bigger ring B, and the small ring is this is within it, and this is dead dash. Here this dash means it is other side of the horizontal ring. Understand? You understand that? And what is the next question? Okay. A long straight wire of circular cross section with radius A carries a steady current I. The current I is uniformly distributed across this cross section. The plot of magnitude of magnetic field B with distance R from the center of the wire is given B. Means there is our wire, there is a wire, okay. We have two conditions. Mean we have to plot R versus B graph, and R on the x-axis and B on the y-axis. Okay. So if you recall the formula, uh, if we go through Ampere circuital law, that is B dot dl is equal to mu naught I enclosed, right? If B talking about R less than capital R, let us call that as capital R, and what we get, V dot dl, what is dl, that is 2 pi small r is equal to mu naught, what is I enclosed, that is I into r square upon r square, that I mentioned you in, मैंने पहले बताया था ना आपको, ये वाला, ये तो मैं करवा चुका हूँ, ये वाला मैंने करवाया है ना। ये वाला मैंने करवाया कि नहीं प्लीज। ये वाला मैंने अभी थोड़ी देर प्रूव करवाया था पहले कि किसी पर्टिकुलर रीजन से करंट डेंसिटी के थ्रू कैसे अपन वो निकालते हैं करंट। ओके, इसको मैं फिर से नहीं करवाने वाला, प्लीज फोकस हियर। फ्रॉम हियर वी गेट b is equal to mu naught I r upon 2 pi r square. From here you can see b is directly proportional to r, b is directly proportional to r. So if r is equal to 0, what is magnetic field, that is equal to 0. Understand? As the r increases, the magnetic field also increases. Means if I draw from 0, it is directly increasing. Okay, and it is maximum at r is equal to capital R. And what is that? What is the value of magnetic field at capital R? If you put r here and this cancel out this, that is equal to, here is, it is mu naught I upon 2 pi r, that is capital R. Understand? Do you understand this? And now for the r greater than capital R, that is b dot dl, that is 2 pi capital R enclosed. Okay, I call this as R enclosed is equal to mu naught I enclosed, that is equal to capital I. That is, if I take a bigger loop, then the I enclosed between the inside this is capital I. From here we get B is equal to mu naught I upon 2 pi R E. From here you can see beta B is inversely proportional to RE. Okay, as the distance increases, our magnetic field is decreases. So here is our the final B versus R curve. Understand? You do nothing, just you have to find the two conditions for 2 points. Okay, आपको 2 points के लिए दो कंडीशन चाहिए, एक इसके लिए और एक इसके लिए। ये समझ में आया? ठीक है, ये समझ में आया कि नहीं आपको? आज के लिए इतना ही रखते हैं, फिर ज़्यादा क्लास लंबा हो जाता है तो फिर बोरिंग लगने लगता है, फिर देखते नहीं है लड़के। समझ में आया ये? ठीक है, ये वाला समझा। अगर कोई डाउट हो तो आप कमेंट कर सकते हैं, मैं देख रहा हूँ अभी। राइट। सो आज के लिए इतना ही है। कल अपन और आगे नेक्स्ट क्वेश्चन देखते हैं। आगे वाले जितने क्वेश्चन है, अभी कुछ बचे हैं, 7 8 क्वेश्चन हैं अभी, अच्छे करने लायक हैं, इनको भी देखते हैं। ठीक है, आप खुद से भी ट्राई कीजिए। ठीक है, आज के लिए इतना ही है। थैंक यू ऑल ऑफ यू, एंड अच्छे से पढ़िएगा। प्लीज़ फोकस ऑन द स्टडी। क्वेश्चन अच्छे अच्छे आते हैं मेंस में, ऐसा नहीं है कि सिंपल आते हैं। ठीक है, प्लीज़ फोकस। और प्लीज़ क्लास ख़त्म होने के बाद एक बार आप वापस से क्वेश्चन को खुद से ट्राई किया करो कि आपको समझ में आया कि नहीं, कोई कॉन्सेप्ट एरर हो या फिर आपको कैलकुलेशन एरर हो, आप कमेंट कर सकते हैं, मैं उसको सही करूँगा। लेकिन प्लीज़ आप खुद से भी फोकस दीजिए, और जो टफ क्वेश्चन है उसको एक बार दो बार जरूर देखिए, लाइक दिस। ओके, और अच्छे से पढ़ाई कीजिए, एंजॉय कीजिए। थैंक यू।